All right, so what is logarithm? Logarithm is a way for you to figure out what the exponent will be, since our exponential function has the unknown in the exponent position. Using log helps you figure out what that value is going to be for x, okay? So the way that we read logs is written right here, okay? Right there. Log base b of a equals to x, okay? The a part is your answer in exponential form, okay? Your b is your base to your exponential form, and x is your unknown in exponential form, meaning this. I'm going to try to color code them. B is the base in my exponential form. X is your exponent to that base, b, and that equals to your a. Okay. So if I have like 3 to the second power, what would that equal to? 9. So you would write log. So if I say 3 to the second power equals to 9, the log version of it would be log base 3 of 9 equals to 2. Okay? So, I already have it, number 1. That's what it is. So how would we write it in exponential form? We would write the 3 from the base of the log, and then we're going to put the 2 as the exponent, and that is going to equal what we're taking log base 3 of. So we're taking base 3. This 9 is now what it's equal to. Okay, I try to color code it so you can see each part. Okay, questions so far? Log base 6 of 216 equals to 3. Okay, which part is the base to my exponential form? 6. 6 is my base to my exponential form. Which one is my exponent? 216 or the 3? The 3 is my exponent, so that's 3. Equals to, what's my answer to that exponential form? 216. Let's check on your calculator. 6 to the third power. 6 to the third power. What do you get? 216. Log base 7 of 1 equals to 0. So how do we write it as exponential form? 7 is the base. 0 is the exponent. Equals to 1. Is that true? Yeah, any number to the 0 power equals to 1, right? So if you have a base of 100, let's say, right? If I do 100 for the base, log base 100 of 1 equals to 0, would that be true? Log base 100 of 1 equals to 0. Yeah. Okay, any questions? Awesome, here we go. Let's see, log base 2 of 16 equals to 4. So what's my base? 2. What's my exponent? 4 equals to 16. Is that true? Yeah? Okay. So do number 5 and 6 for me, and then you can check your answers with me. Okay. Okay, remember what we just did in the last unit? Rewriting this 9 to the 3/2 power as a radical? You don't have to, but you can check even without a calculator because you know how to do it, right? So that means that it's what's the index of my root? It's 2, right? So you would write square root of 9 3 times inside, right? So I would take one set of 9 out. Then square root of 9 is 3. So what's 9 times 3? 27. Okay? Does that make sense? Okay, let's try this one. 4 to the negative second power. Okay. 4 to the negative second power means that it's 1, you take the reciprocal of the base and then raise it to second power, positive, right? Then that would equal to 1 over 16. And it's exactly the same, right? Is it coming back a little bit? You have to not forget those things. You have to add to what you learned from last unit to what we know now. You cannot throw it out the window because it's done and gone. It's not done and gone. It's coming back. And I'm going to make the problems, the more challenging problems, are the kinds that reach as far as like unit 1. And I bring in all the pieces. Okay? So making that connection shows ultimate mastery. So you need to make sure you are capable of adding more layers to your understanding, not surface level. All right? Okay, here we go. We're going backwards now. Exponential to logs. We're given an exponential function. This is my base. So I would write log, okay, of base 14 of, my answer is 196. By the way, this is also called an argument or an answer. It means the same thing. When they say, what is the argument of this log? They're asking for the answer, okay? The 196 is your argument, okay? And then that equals to your exponent too, okay? Any questions? Green is the argument. So meaning, okay, let me write it out. If b to the x power equals to a, right? Then we can change it to log form. Sorry, a should be in green, right? That a is what we're taking log of. The base of the log is the base of the exponent. And then the x is going to be what it equals to. Okay. Try number 8. Try number 8 if you haven't. This is confusing, so definitely color coding is going to help, right? The base of this exponent is this 12 right here, okay? That 12 is going to be the base of my log, which is 12. And if I take this piece, the 12, it would be this 12. And that equals to 1, the exponent. Okay, the argument to the exponential form, the answer to the exponential form is what we're taking log of. The base is the base of the exponent. Okay, and then 1 is the exponent. Questions? You good? All right, here we go. One more time. Base. The argument or answer, and then our exponent. Next piece is being able to use it like on, let's say, a calculator. Ready? So, let's finish 11 and 12 before we get to that. Okay? Try it out on your own. Look up when you're done so that way you can check your answer against mine. Okay? Try it without looking up. All right, here we go. So you guys know, like, if I say x, what's in front of the x? If I give you a variable x, let's say I have x plus 3, okay? I'm not going to color code it. If I say x plus 3, what's in front of the x? A 1. Yeah? That's invisible. It's known. We accept it. That's a common way to write x. When we have 1x, we write it as x. Are we clear on that? If I have 3x, y equals 3x, what's my b value there? Even though we don't have it here, it means that we're adding what? A 0. This is a common knowledge, yes? Okay. In logs, they have also a common logic, common base. That if you do not see it typed up in the log form, if you don't see a base, that means it's always a 10. The common base is always a 10. Okay? Base 10, this will not always be written. So what they would write is this, log of x. That's it. Okay? If you do not see a base, that means the base is 10. So let's try rewriting these. And then we're going to try to use it on a calculator, okay? Why is this not shown? Change of base formula. Wait. Why is it not shown? Okay, so this is the same thing as what we did in the last part, but we're doing it with different variety of bases, okay? We also have to solve it. Evaluating means that you're solving it. Solve for the unknown. The unknown, in this case, are all the exponents. Okay? I'm writing it in blue on purpose on this one. Okay? So if I were to write this, base 7, I have no idea what this x is, right? So put that x in that spot. What does that equal to? 49, right? What number should I raise it to get 49? 2. So what's my x? 2. There we go. So this equals to 2. Yeah. Log base 7 of 49 is equal to 2. Because 7 to the second power is equal to 49. It makes the argument true. Okay? Makes the answer true. How are we doing? Am I going too fast for anybody? Anybody need me to restate what I just said? How come it equals 2? If I take 7 to some power, it's supposed to equal 49 based on this law, right? What do I need to raise the 7 to make it equal to 49? That's it. Okay? All right. Are we good? Okay. You okay? All right. I'm moving on. Here we go. What's my base to this exponential form for the log? 3. 3 to what power will make it true to equal to 27? 3. 3 to the third power is equal to 27. So this equals to 3. Because that equals to 3. Does that make sense? How we doing? Let me know if I'm moving too fast. Am I still fast? Okay, we're okay. All right, here's the base 10 one. Okay, they want to know what log of 100 is. The way you read it, you don't say base 10. That's like what a noob would say. You just say, if you say log base 10 of 100, that would be a noob thing to say. A pro would say log 100, log of 100. Okay, what's log of 100 equal to? 2. Okay, this equals to 2. Okay, let's revisit this. I have an invisible 10 here. Agreed? Yes? So we write 10 to what power equals to 100? And that would be 2. X has to equal 2 in order for 10 to be raised to a certain power to equal to 100. Okay? How we doing? Check it in. Okay, try the other ones. 16, 17, 18. Try those out. 19 and 20. Look up only if you're ready to see your answer after you try it, okay? Okay, you ready? Okay. Cube root of 64 is 4, right? Yes? Okay. Yes, you could do a whole bunch of plugging in, but it's going to be a pain in the butt. Not every calculator has this function from your graphing calculator, so I'm going to show you how to do it with regular scientific calculator. Okay? And there will be some tests in your life where you take a test with no calculators at all, with logs in them. Okay? Yes, they expect you to know. So the way that we can change the base is by doing this. You can take log of A divided by log of B, and you get the exact same thing as log base B of A. You get exactly the same thing. Okay? So if you put in to your calculator log, which is to the left of your number 7 button. Do you see it? Log of 64 and close the parentheses on it. And then hit divide. And do log again, but this time with 16 instead of changing the base at all. It's going to equal, what do you get? 1.5. Is that what you got? Okay, 1.5 means 1.5, right? Which is also 3/2. Any of those would be acceptable answers for this one. So you can do 3/2 or 1.5 or 1.5. But this is most preferred. Okay. 3/2. If you could write it into a fraction, do it. If you cannot write it into a fraction, this is the second best one, 1.5. Okay? Any questions? Okay. Evaluate each log using change of base formula. So how do I change it? I need you to write this out, okay? You must write this out. We need to write log of 32 over log of 8, and then hit enter. Do you want me to write out the pathway?
Yes, please.
Yes? Okay. So for the first part, it would be just log, and then you would put parentheses 64, close the parentheses, and then do divide by log button again. And then the parentheses automatically opens. My bad. You don't need that one, right? Parenthesis automatically opens. So you just put in 64 divided by log. Don't delete it. Just leave it as it is. 16. And then hit enter. You don't have to close that unless you really want to. And you should get 1.5. Did you get it?
I know, it just needs to be a fraction.
Look, let me show you.
So if you want to change 1.5 to a fraction, what do you do?
It's not that one.
Math 1.
No, it's not doing it.
Yeah, because it's an irrational. If you have an irrational number, it is not going to change it for you. So guess what? When you do log of 54 divided by log of 2, you're going to get a very long decimal, yes? What's the decimal? You're going to round it to the nearest fourth power. Okay? Sorry, not nearest fourth power. Fourth place after the decimal is what I meant. Okay, so I'll add that in here. If you have an irrational, so meaning no pattern, it doesn't end, number as your answer, we're getting into this habit now, okay? I want you to write out up to 4 places after the decimal and round, okay? Meaning this. So I have log of 54, close the parentheses, divide, and log of 2, close the parentheses, and we get 5.7548, but 8 needs to be rounded up to 9 because the next number is 8, right? It was 8, but you write it as 4, 9, not 4, 8. Are we clear on this? If you still don't know how to round properly, you better be seeing me. Okay, swallow that pride and come see me and I'll talk to you through it, okay? All right, ready for the next one? Log of 294 divided by log of base 10. Oh, wait a minute. Do I really need to do base 10? No, so all you have to do is just put in your calculator, log 294, log of 294, and you should get your answer that you're looking for. Okay, so if I do log 294, and I get 2.4683473, so I'm gonna go up to the fourth place, which is 3. I look to my right and I see 4, which is less than 5. So you leave it as it is. So this would be log, write this out, by the way, 136. I want to know what you put into your calculator. Okay. Log of 4. Oh, sorry. I jumped over. My bad. It should be 2.4683. And if we round 3 by looking at 4, it should stay as 3. Okay. All right. Next one. Let's do log of 136. Close it. Divided by log of 4. And you get 3.54373. So since to the right of 7 is 3, it's less than 5, you leave it as 7 for the fourth place after the decimal, okay? All right. Last one, and then we'll pack up. log of 136 divided by log of 6. I think that's negative second power, right? So log 36 divided by log of 6, and it's 1 over 36. Oopsie. Second, insert parentheses 1 divided by 36. All right, your homework is the next page. Practice it so you don't lose it. And then we'll do something fun on Wednesday to practice these, okay? All right, bye. Have a great day.